you see, it's our sponsors. We leave only because of that company. Actually, if you want to help us too, you can do that the same. We should not be a big company, of course. All instruction in our site, DEVCLUB.EE. And also, if you want to be a speakers, you can find information about it there too. There should be some person who want to say a few words. It's Ivo from Playtech. Welcome.
Thank you. Good to see you all here. I'm Ivo, director of Playtech Estonia. Before I will forget, today's main person who is behind this event, Darja Lamova, asked me to say some few organizational points that we have today. Two presentations, one from Valdo, second from Sergei. And between the presentations, there is a short break when you can some snacks, and also we have short office tours. And after presentations, then you can stay here for until 10 o'clock to discuss further. But yeah, from our side, yeah, definitely here in Playtech, we are delighted to welcome software maestros in our space. It's proud to see you here. Today's evening, definitely, it's very important from that point of view that you can share your knowledge, looking more new opportunities, new solutions to build more these companies where you are working today. As you know, Playtech is already unicorn, but there is a lot more room for other unicorns. So we are happy to see if some of you will build second or 11th one already in Estonia. So it's definitely a place for that. Here, what we are proud, especially in Playtech, is that our average seniority is more than 6.5 years. We have more than 200 employees who have been working here more than 10 years. And Valdo is one of them, of course. He's been here already more than 13 years, so you can be count on it that he knows what he is talking about. And also, yeah, I'm not wasting more time. I'm not gonna talk about Playtech that much because Valdo will cover that part. So Valdo, please, the stage is yours. Thank you.
All right, good evening. First of all, thank you all for coming. Thanks to DEVCLUB for providing the opportunity for this topic. Also, thank you Playtech for the trust on this. We'll probably not be making that mistake ever again, but let's see how it pans out. So the golden rule of every presentation is usually that you start with a joke. If people laugh, it's good. If they don't, it's probably the lowest point in your presentation anyhow, so there goes. I know a lot of jokes, but there's only one about developers that I know. So, question, why does a developer put two glasses next to his bed when he's going to sleep? One filled with water, one without. Anybody knows? Yes, exactly. So basically, if he wants a drink during the night, he uses the filled one. If he doesn't, well, he doesn't. So there goes. As Ivo said, my name is Valdo. I've been with Playtech for about 13.5 years. I've always been an infra guy. The closest I have ever been to development was writing C++ in university. I realized that I really admire you folks. I couldn't ever do it. Just no. I'm sorry, but no. Today's topic, running a private cloud, the good, bad, and ugly. It will pretty much only cover the tip of the iceberg. Basically, why Playtech does things the way we do. I will start with not the, let's say, main topic, but I will start with a brief background or history of Playtech, just to get the understanding maybe a bit more why things are as they are. So before I turn to my next slide, or let's start with here. So what is Playtech? You'll probably, majority of you have heard the name, I at least hope. In Tartu it is quite simple. You mention Playtech, in Tartu there's 100,000 people, give or take, like 1.2, 1.5% of them at some point in the last 20 years have worked in that building or in that environment. Now, the others, if they haven't worked, at least know someone who is working and what Playtech does. But if I would ask from you guys, what would be the keywords that come to your mind when talking about Playtech? Anything else? Well, a unicorn is yeah, a good one. So we are one of the unicorns, indeed. So we are an online casino provider, and we are an IT company. That's pretty much it. You can't get more usually. So what usually doesn't come up is that we have been an innovator and a market leader on this stage for about 20 years. Literally, Playtech is the one that is doing the stuff where the market goes. Social responsibility and responsible gaming. So at Playtech, we are committed to growing our business in a way that has a positive impact on the people, our communities, the environment, and the industry itself. Also, the responsible gambling part, a big part of Playtech offering, we will get there a bit later as well, a bit longer, is basically Bet Buddy, which is a groundbreaking responsible gaming platform that combines all of the latest trends on how to make sure that people are actually gaming and gambling very responsibly, and we get all the, let's say, bad behaviors before they actually turn into something really bad. We deal with a lot of compliance and regulated markets. So all of the internal schoolings, all of the regulations we have to fulfill. And also our branding, which is Playtech One and Playtech People. Playtech One, we will get there in a minute as well, but it's basically our business branding for our omni-channel platform. What is Playtech People? It might sound like a cliche, but this basically is the brand that is there for us, the people in Playtech. So why I'm saying it might sound like a cliche, all of those big companies that say that, oh, our people are the most valuable asset we have. Usually, yeah, not really. In Playtech, you can actually feel it. So as you might or might not know, also, I'll get to that part as well, but we have offices in 24 different countries. One of them is in Kiev, Ukraine, which has been ravaged by war for like almost 2 years. And the other one is also in Tel Aviv, Israel, which is also in a bad situation. Now, Playtech has a support network for all of those people. We're communicating, we're providing, we're helping. So you can actually feel as one big happy family. No pun intended. That's the way it is. So, short history. How did we get to today? So Playtech was founded in 1999. Back then, it was not yet named Playtech. That name came in 2000. So initially, it was Trinet OÜ. In 2001, first servers were set up, first licensee. 2003, first live casino studio, first bingo network. 2004, iPoker network, video bet. Videobit is actually working right here in Tallinn, providing land-based terminals all over the world. In 2005, mobile gaming. So how many people had phones in 2005 that could actually do something other than the snake game? Not too many, right? But hey, we did mobile gaming. So 2006, important milestone. We might not be having this conversation here today. Playtech went to the London Stock Exchange alternative market, but also in 2006, AWS public cloud launched. We could be on that, we're not. Why? There's a reason. We'll get to that. 2008, 2009, first regulated markets, also sports betting. 2011, first game studio. So basically up to that point, all of the games were like done in-house. Then like a sub-sister company was acquired. 2012, London Stock Exchange main list. So we're publicly in the market now. 2013, acquiring Poker Strategy, the biggest poker network in the world, basically. 2015, now this is the Playtech One, the omni-channel solution. This in terms means that if you have one account, you can use it on mobile, you can use it on your laptop, you can use it on land-based terminals. Pretty much all of the solutions we're providing, you can use the very same account there. In 2017, the Pet Buddy, which I also already mentioned, for all of the responsible gaming, responsible gambling stuff. The Warner Bros. Content deal, which is like a huge thing because like many of the Playtech content branded games are using the Warner Brothers, let's say superheroes, stuff like that. And also Snaitech acquisition, which has been the biggest acquisition Playtech has made to date. So for the products we are providing, this is pretty much it. The central part is on the rightmost corner, the Playtech IMS. This is like the thing to run. So it is providing all the functionality for handling players, all of the financial stuff, and also the responsible gaming part. So this is the leading part of the platform we were talking about before. So Playtech in numbers. As I said, we have 24 different locations and offices, more than 7,000 people globally. 150 plus business customers. When we're talking about business customers, we're actually talking about license holders. Now, Playtech doesn't have any casinos on its own. We are just providing the platform, the games, the subsystems, but we are not actually hosting any of the casinos ourselves. This is for us, the customers, the licensees. So the local market license holders. And we're working in more than 30 plus regulated markets. Now regulations come in different forms, different sizes. We'll discuss about it a bit later as well. Now in Estonia, we have 750 plus employees. 13% of them are from foreign countries, 37 different citizenships. 30% women, 70% men. We are like trying to get more women on board. Should be 50-50, right? Maybe 60-40. So all of you ladies here, Playtech, waiting. Average age of the employees, 34 years. Now, as Ivo said before, there's 200 plus people who have been working with Playtech for over 10 years. Now, I am one of the proud owners of the oldest teams in Playtech. So my team average employee age or employment age is about 13.9 years. So me, myself, with my 13.5, I'm still below average. And now to get to that part, which is actually running the private cloud, what we will be discussing about, then it's Playtech infrastructure unit. So 109 people out of those 7,000 plus are actually the ones responsible for the actual private cloud part. Now, where it all began, still history. So as I said, first service in Antigua, 2001. Very simple setup, very few products. Well, I'm saying limited automations, but initially pretty much no automations. Sun servers, HP ProLiant servers for firewalls, HP switches. That's pretty much it. Bits and pieces, but that's pretty much it. So how this can't be private cloud, right? Can't be, no. So you have to get to the private cloud part somehow. So you have to migrate. Migration process. So the first new generation of sites was built in 2010. It was actually in Finland. And this is where we actually got to the virtualization, the x86 application platform, load balancers, all of that good stuff. Now, this is something we could already start calling cloud. Not quite there yet, but this is sort of a private cloud there. By the way, what I forgot to mention in the very beginning, I would like for you guys, if you have any questions, remarks, something, just hand up, just ask. I would like to have sort of an interactive, not me blammering here for 45 minutes straight. So, is that the deal? Sounds good? Awesome, thank you. So, what are we looking at? This is pretty much the cloud layer, the hardware layer of the cloud. Now, Playtech hosts two sort of sites. One sort is standalone sites, which means that they are built purposely for one licensee and one licensee only. So one license holder, one very specific company. In that case, usually you only get like half of this picture. So you divide it in the middle. This is like the cloud setup. The full picture represents what we like to call a shared site. So this is for those licensees who don't actually want to have their own platform, but they want their casinos and you know the share that they are just basically being billed on monthly basis on what they use. Now this is where we already are getting to the private cloud part. So similar to AWS, where you get the EC2 instances, your S3 buckets, your egress traffic that costs a lot. So we can do pretty much all of that here as well. So yeah, as you can see, pretty much everything, or let's say everything except the storage devices is always at least doubled. So there might be cases where the application servers are running like 30 of them in one cluster. Might be a bit less, might be a bit more, but everything except the storage. So if you have the shared site, you also get 2 storages, in some cases even 3 or 4, but in standalone cases, basically we know that storage itself has enough redundancy in it, so like 3 controllers, all of the very different disks, so you don't actually have to put several of them in one place. Now, if you go away from the actual physical layer, then this is kind of what it looks like. Now, the image is a bit wrong, talking about the database network. The Oracle and MariaDB are not the only ones. There's also on the database level, like Postgres, MySQL databases, stuff like that. But the general idea remains the same. You have several different security zones for different VMs, or again, for those of you who are more like AWS people, for the EC2 instances. And yeah, you have the load balancers and everything. So the cute kitten pictures come from the internet part there. So yeah, this is now the services that we're actually running. There's a lot of them. I'll be covering some of them more in depth. But yeah, there are things that we either have to buy in fully, like the DC services. So Playtech is not running anything on its own premises. We only have we have our own data centers as well. You will probably, during the office tour, I hope they show you the server room in this office. It's quite nice, all the LEDs and stuff. We have pretty much something in each office, but this is only for lab and development and stuff like that. So all of the production things are actually being run from very specific data centers, that the service providers that actually do the hosting as living. So DDoS migration, this is a multi-level thing. The ISP DDoS protection is something we purchase. We also have our own DDoS protection layer as well, built inside the site for like smaller and sort of other angles or other vectors. Now CDN and also file origin, that we have, I think, 5 providers in total. We also have our very own hosted CDN and file origin network, just to add more redundancy. So again, you can't host everything from Europe basically, because if you have gaming from Asia, gaming from Americas, then the latency would be bad. So you have to have like a global presence. The external DNS services also basically purchased in. We are still managing, we're still like purchasing or renting the platform. And also the hypervisor platform is the same. We are getting it from a third party. Now, monitoring solution, we'll be talking about that a bit longer later. The Artifactory, again, our own hosted. Data analytics and formulas platform. Now this is basically the full capacity management. This is sort of a nightmare, but again, getting to that part later. All of configuration databases, pretty much managed in-house. Orchestration, automation, and management tools. We'll be covering a good part of them in the next slide. Several different discovery solutions. Also IDP and authorization systems. Well, those are like both in-house and then from outside. Logging solutions. Also we'll be discussing later 2 different sets of logs. Systematic logs or system logs, and also application logs. Stanimir here was talking about them in Digit conference a bit longer, but yeah, those are amazing systems. And also network proxy solutions. Now, as I'm stating on that slide, this is not the full list. If I would have listed everything, we would take like 2 hours just on that slide. So not to bother you. Now, amazing things, actually. So there are several different teams in Playtech that, or in infra, that are doing development. Even in my own team, there are some developers in our network part, in our database team, but there's very specific platform team in infra that is actually doing like big part of the management systems. So this is, I think, one of the key points to take away here, that we are not in the platform management realm doing things with, or at least only with like those big enterprise solutions. We don't want to get vendor locked. So we have huge in-house built systems just for the platform management and all of the automation solutions. So what the picture here shows, it's kind of fuzzy, I'm sorry, it should be clearer, but this is called CEMIC. So, and it's end-to-end built in-house software. And as you can see, it's used for a lot of things. Again, not an exclusive list. That's like, as you can see, all of those are here as well, and there are drop downs. But yeah, you can do pretty much a big portion of the management here. So just a few examples, all of the CDN management, certificate creation, replacing, etc., all really cool, but I'll show you the statistics a bit later as well. But just as sort of a heads up, what this thing is managing is around 25,000 VMs in total. So we have some 15,000 VMs in production and around 10,000 VMs in dev and lab side and stagings. So pretty much all of the redeployments, reconfigurations, stuff like that, all goes through this single management interface. Really neat, really nice, all fully built in-house. Oh, software. As I said, 109 people in infrastructure department, about half of them are doing project management, change management, all of the different sync meetings with product, stuff like that, and about 50 plus the platform people, so around 60 plus people are dealing with actually the software part. With those 60 people, we just compiled the latest version of our, how to put it, well, the full list of the softwares that we are actually providing and supporting for the platform. The list came up to be 208 different softwares. Now, the CEMIC that I just showed you is counted as one. And we have 208. Indeed, some of them are really small, just doing one task, but there are really big ones as well. Now, some statistics. We don't have the 2023 numbers yet, but as I said, something like 15,000 virtual servers in production. Also, the physical devices, as you can see, in the end of 2022, we had almost 3,300 physical pieces of servers. Now, that's I'm not sure if it's here. No, it's on another slide later. But next to that is also like a good 1,500 pieces of network equipment as well. So the very same team again. So it's 109 people, 5,000 pieces of physical hardware. It's not just purchasing the hardware, managing it. It's all the security patching, the installations, all the upgrades, pretty much everything you need. Now, majority of the configurations, upgrades, etc., are once again done with automations. This is one thing we are very good in. So, as we have, as I said, 109 people, you can't do it click, 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 click. just go nuts. You'll never getting it done. So automation is the key here. And again, very big part of those things we use as automations are in-house built. The engines might be taken from open source things, but majority of the coding is in-house. Now the locations, just as I said before, we have like a global presence. These are the data centers that we're currently running in. Asia has gotten a bit small. This is currently Taiwan you're looking there. We also had things in Singapore, in the Philippines. Both of those locations, unfortunately, decided on zero gaming laws, so we had to pull everything out. So this is a big part of the regulated markets that I was talking about before. So it's not just about meeting the local laws. So in order you would be able to provide a service, but it's also that if the local laws state that you have 2 months to get out, or everything will be taken from you, then you have 2 months to get out. That's how easy it is. As you can see, we're getting back to the USAs. This is actually a new thing. This is one of our biggest growing markets currently. But just as background, back in 2007, I might be lying here, I think it was 2007. Actually, before that, we were in the USA. But at some point in that time frame, USA basically said that from tomorrow, actually they didn't provide any heads up. They said that by starting from tomorrow, all of the gaming is illegal and you have to shut down everything. So basically during the night, Playtech shut everything down. We were out of the market. Many other companies stayed. Now the federal laws are open again. Playtech can go back. None of the companies who stayed back in 2007 can't legally go back. They're just not allowed. Simple as that. So capacity management, as I said, sort of a nightmare. 100 production sites, 60 physical sites in 30 plus different data centers. Translates into roughly 135 different application clusters, 1,600 physical servers, 57 storages. Storages are in full capacity or at around 37 petabytes of data. These are the amounts we are running about. So 25,000 virtual machines, already talked about. Now the sites, servers, services, they all need to be monitored when capacity would exceed and when is the best time to start upgrading, purchasing new equipment or reconfiguring the hardware and software. Now the hardware equipment cost and installation are, as you can imagine, expensive, and also the delivery lead times are very long. So it's important to purchase at right time. This is why every component needs to be investigated very closely. So the target is to provide the service availability from resource and time point of view. So the game stats are always ever growing, and we always have to evaluate also the new components, new requests for launches, and everything like that. As you can imagine, that cannot be done manually. It actually, in the past, it used to be a Microsoft Excel exercise, basically. There were tremendous Excel files with tens of thousands of rows. Just can't do that. Now, what was done? 2 different tools, basically. I'll let you read the main challenges part by yourself while I talk. So DAF, the data analytics and formulas platform, basically was one part that came alive from the very same Excel files. It is pretty much, how to put it, it is partly AI-based, again, fully in-house built system. So we have, as you might or might not have already figured, in infrastructure department, we don't have too many actual IT people. So majority of the people working in the capacity team are actually mathematicians. So this is why they can build such cool things. So the second part is the infra product cost management tool. This does two things, or does a lot more, but like two different categories. First of all, as I mentioned before, we have those shared sites to provide like the service to many different customers, many different licensees. You have to know how to build them. How much of the actual site's resources are being used, what does each resource cost? So again, the very same as in AWS. You use one EC2 instance, it costs amount of X. You upgrade it by memory, by CPU, costs more. You do more traffic, you pay more, you write more logs, you pay more, you use more S3 or storage in general, you pay extra. So this is one thing. And also, as you might or might not imagine, infrastructure department itself is a cost unit. It's always a cost unit. You are not providing like a valuable service for the end user. It's just something that, majority of the people, even inside Playtech, majority of the people don't really see that there is like something under there. If you're, I'm not putting this, this isn't as bad as it sounds, but from developer point of view, you don't actually need to know where you're deploying your code to. You just need a working platform. If you have it, how it works, what the magic is being done there, you don't really care. Now, as we pointed out, more than 7,000 people in Playtech, 100 of them in infra. So the rest of the like 6,900 people are doing something that is pretty much utilizing that platform. And just to get all of like the money straight, you have to also know how to bill virtually in the inside. So we aren't actually billing anybody in the inside, but you have to know that if one product is doing like 5% of the money for the company, but using 60% of the resources, you have to know that, because this is not balanced math. So you have to figure it out some way. Now, how to actually know what is worth doing and what is not? Similar to many other teams in Playtech, or let's say departments in Playtech, infra is also running a program and projects board. So we define them in 3 different categories. So business roadmap and licensee projects, which is pretty much where the money comes from. So new sites, new licensees, new brands, etc., etc. And it's product support and infra product alignment, which in terms means that how we can actually provide services to other departments and how we can align with them. So in an ideal world, we would know what the products are doing, products would know what infra is doing. We don't live in an ideal world, unfortunately. So there is like a lot of gaps, a lot of communication is needed. In many ways, product needs some different sorts of configurations on top of infra platform in the very same private cloud, basically. and we just can't do them like that. Again, 109 people, we just don't have the manpower for it. So it has to be prioritized, has to be figured out what exactly is needed. And then there's also the internal roadmap and platform development. From the CEMIC picture before, some of the platform development is going excellently. Developers are doing excellent job. And then, the internal roadmap, there's two parts. The parts that get done, and then you have the technical depth. Because if one of the troubles with running such a system is that you have limited resources. With the limited resources, if you have an option to do a licensee project or the technical depth part, money pays. You always have to do the licensee project. And then you have to figure out how can I actually put in the time to run. So this actually doesn't only cover the program part. As I said before, almost half of the, pretty much half of the department is also project managers, because somebody has to run those projects, manage, plan, coordinate. Then you have the change coordinators. Because as you can imagine, if you have 150 licensees over the site, you can't just go in doing the changes. If they are seamless, yeah, maybe. If they need some sort of a downtime, maintenance, whatever, you have to have those things written down, agreed, also with internal resources. And also, as I mentioned, the internal communication, so we have a separate team in place just for the internal communication, just with the products. Now, interesting part, or the most difficult part, let's say, the regulation and audit support. Now, Playtech in general is doing hundreds and hundreds of audits each year, very different ones. Infra is part in only some of them. Infra is running, I think, around 50 audits in a year. So let's say roughly one a week. So they are being run in parallel. Some of them are very small, only a few hours. Some of them take 2 weeks. There's very, very different ones. The local, online, but the auditor actually comes to you. You have online sessions. The internal, external might be also management audit, where management wants to know how this or that department is working or what is being done. Pre-planned, ad hoc. So pre-planned is nice, you know what to expect. Ad hoc pretty much means that at one point the auditor comes in and says that we want to see this and that, and you have to provide the information. And also the regulator-specific audits, where the actual country local regulator itself wants to do the audit, or then the audit company. Again, the US case is one of the best, where pretty much all of the local states require some sort of audits. In many cases, not even yearly basis, but quarterly based audits, and they have very specific audit companies provided for that. So you can't do it directly with them. You can't choose the auditor. They have very specific audit companies in place. On the right side, it's just a small list, just for you to see how many different. This is part of them. There's more, but this is the main ones. The most interesting probably out of this list is the BSI DSS audit. Probably there's some guys here from some companies that are also dealing with it. I presume that at least some of you have seen the BSI DSS audit. I saw at least one nodding his head. So yeah, basically this is credit card data audit. Basically, they have very strict requirements, and it's an interesting one. Now to visualize it a bit better, this is let's say infrastructure only covers the first 4, and this is only for the European markets. But just to get an understanding how much you actually have to do the audits. Now, still have a bit of time. So, monitoring. So how do I know that the things are actually working? So you have a private cloud in place, you have your applications in place, everything's working. How do you know it's working? So it's not even simplified, but this is pretty much what you get. In Playtech, each product is pretty much responsible for its monitoring. We have, let's say, very general platform provided, but they can customize it in many ways. Also, what's missing from this picture, my team is one of those who are doing it, also some others. Some of the teams have their very own monitoring solutions in place just to filter out the critical or like the important pieces of alerts before they ever get to these dashboards. This is pretty much to guarantee that you don't get woken up during the night more than you actually need to be woken up. But yeah. So this is theory. Let's talk about practice and monitoring. As I said, it's fully customizable for the product. We have, again, a separate dashboard, separate tool for that. Can go into the details, configure everything. Now, this is probably one of the coolest parts about the monitoring. In the last picture, there was a box that was labeled PT bus. So this is prediction-based monitoring part. So this is live data, basically. It's using data from last 2 weeks at each given point in time. Now you have your high watermark, your low watermark. The blue line you can see here is the prediction where by our knowledge, where the gameplay should be. Well, this graph is gameplays per minute, basically, in one site. And it's going good, going good, going good. And as you can see, at the red cross, something happened. This happens, you get an alert. Not a ticket, but an alert that somebody has to come online and fix it. No, I'm keeping you from your break, but let's do this quickly. Now, as I mentioned before, there's 2 types of logging on that platform. Everybody loves logs. It's like, as I said before, we have 37 petabytes of storage in total. I think we're using around 10 petabytes of that just to store logs. Amazing. We just delete them at some points, but yeah, you need them. So 2 different types. So system logging for basically all audit, file integrity, etc., etc. So everything that's going on system level. Those logs are generally kept for 90 days, unless the local regulator says otherwise. In some cases, they are also kept for half a year or even a year. Fortunately for us, those cases are rare and far in between, but they are still there. Now, application logging. If you have any questions, and Stanimir here can raise his hand. So So during the break, he can go in depth. He has an amazing performance from Digit conference. You can actually look it up. But basically, yeah, Playtech application logging has massive amounts of logs, massive amounts of text files. Now, I think, correct me please if I'm wrong, it was done somewhere over the summer, the C standard was introduced, right? So basically, as you can see from the pictures, what pretty much happened, the time for log management, especially the decryption or the unpacking part, was halved. And that's what actually matters to the users. You don't really care how fast the logs are being written, but you have to see, you kinda, yeah, but still, as long as they are being written, then you don't really care. But if you're reading them, if you're working with them, you need them fast. Now with this thing, the time was pretty much halved. And if you look at the size, and this is also important, as I said, we have around 10 petabytes of logs in total over the sites. As you can see, from 2 gigabytes to 931 megabytes, and from 508 megabytes to 32. So it's amazing. You can just cut logs in halves. But yeah, basically, again, application logs usually kept for 30 days. In some of the regulations, up to 180 days. Now, our all favorite part. So, it ain't as bad. It ain't also much better, but the security. You have to deal with this sort of platform with vulnerabilities, with very specific questions, who can access and what can they access. So in an ideal world, again, least privileged spaces. In reality, it's actually quite difficult to manage. Because as said, only on infra level, we have 208 services. Products want to use them, well, in different ways, and not ideally in a way security would like them to happen. So nobody told anything throughout the whole thing. Again, as I said, we were touching only like a tip of the iceberg here. We could be covering any part of those topics like for hours or for days, because it is a huge system. But I hope you got some sort of an understanding why Playtech is actually doing things the way we are. Now, to be fully honest here, it's not like we're only running on that platform. We have supportive services already for years already. Running in Google Cloud, in AWS. There's also POCs ongoing to run the actual sites in AWS. Just to understand if it's even feasible. But just for the sake of the regulations and other needs, because many of the regulations actually specify that your hardware, your software has to be in a specific location. You can't run US Oklahoma, for example. I think one of the harshest regulations we have, they are very specific even by the data center where you can run your stuff from. You can't actually just put them in an AWS account and say that they're done running. So this is the reason why we're doing it. So yeah, it's basically for you to figure out if it's good, bad, or ugly. I personally think it's awesome. Thank you. Yeah.
You had on one slide that major alerts, they need to be handled within the one working day, basically. Can you give some examples of that? And are you doing also like a post-mortem, what you're sharing with, if you have
Yeah, there are well, basically different alerts. So there are the critical ones, who, like during the nighttime, basically within minutes, on-call specialists are brought online. They fix it. There's for those, there's always post-mortem. So there's the root cause analysis. After it's being fixed, the specialists provide their input. We analyze it, why it happened, how can we actually make sure that it will not be happening again, what are the fixes being implemented across all other sites, what are the procedures that need to be changed, etc., etc. So with the ticket-based things, let's say the major ones, yeah, that only produce a ticket, but don't actually produce the on-call alert and can be handled the next business day, not during like the night hours. Then in those cases, in majority of the times, from the first ticket, no RCA is created. It's pretty much fixed, handled. But we can correlate. So if it keeps happening, then in correlation, we start doing RCAs and looking into it, why it keeps happening. So yeah, it's pretty much a self-fixing system.
Do you share also like learnings? I know that Cloudflare had an issue. They were down like 2 days and people were really angry, but they made a really like a deep post-mortem later and they said, okay, that's they explained really well and they understood that. But like a lot of businesses were suffering because of that. So do you share also that kind of learnings if something
yeah,
fails?
basically if we have in any of the sites, if we have like big downtimes, the priority A, priority B incidents where the site actually goes down, or at least part of the services go down, then yeah, a full timeline with the analysis is also provided for all of the licensees. So yeah, this is done depending on the licensee. In some cases, we have a few days to do that. In some cases, you pretty much have to submit it within hours.
Thank you.
Thanks. Yeah.
On the one slide, you had you have that your licensees have their own services, servers, and how you guys are you guys delivering your products to their services?
Yeah, I might. Well, maybe I was. If I'm getting your question correctly, so in majority of the cases, the hardware is still like owned by Playtech. And provided just as a platform, so licenses rent. But indeed, there are a few customers that are actually purchasing their own hardware. Now, this is still being done by the very specifications of Playtech. So our capacity management still is doing like all of the calculations, how many of what they need. Also, we are providing the very specific brands and all of the configurations that have to be in the server, and the licensee is just buying it. And then once they have racked it and provided access, we still configure it.
Okay, and you are delivering your products to
their
server. Okay, then how you are protecting your intellectual property then?
Well, the licensees don't have such access to the systems anymore. Basically, when they provide access to us, so they have put the servers up, the servers are up and running, then we pretty much come in, change all of the needed accesses, passwords, etc., etc. So all of the security will be still in place for Playtech. We have a few, I think, pretty much like 2 of the licensees who do part of the management themselves, like firewall management or storage management. But even in those cases, all of the data is still being encrypted. All of the database data is always encrypted. and also with the agreements, or basically the SLAs we have in place with the licensees, the product as is still Playtech intellectual property, and they can't use it, even if they can see it, let's say, on the VMs. If they, well, okay, the VM, that's a bad example. They can't access it because that's for us only. Let's say the guys who are managing their own storage, they basically can see the encrypted data, but they can't actually do anything with it.
Okay, thank you.
Thank you for your speaking.
Thank you.
We have a small present for suitable size.
Thank you.
Thank you.
Thanks.
And now welcome to the kitchen, get a snack, networking, and there should be some tour around the office. Yeah.
Yes, thank you very much, Valdo, and thank you everyone for listening and for your questions. There are some burgers ready for you. Please have a bite. And I think we will be ready to start office tours also for those who are interested in 10 minutes. There's Lenne. She will be taking part of you. And then there's Raul. He will also be taking a part of you. So once you're done with eating, please find those two guys and they will show you our office. Thanks. Check, check. Hello again. Final call for office tours. If you want to go, then Lenne is there, and Raul is where? On the right. We are starting now. Thank you.
founded in Tartu, Estonia by 2 Estonian students and an Israeli investor. This was the start of the unicorn. With the arrival of the new millennium, Playtech started to develop rapidly. In 2001, the first server was set up on the island of Antigua and the first casino licensee was welcomed. In 2003, Live Casino Studio was launched in the Philippines, so players could experience the thrill of real-time casino gameplay. Also, Playtech's Bingo network hit the market and became an instant success. 2004, when Mark Zuckerberg created the social network Facebook, Playtech launched the soon-to-be world's largest online poker network called iPoker. Also, with the launch of VideoBet in Estonia, Playtech entered the land-based gaming terminals market and opened an office in Tallinn on Paldiski Road. Mobile gaming was launched the following year, enabling players to play on the go. 2006 was a monumentous year for Playtech, as Playtech's shares were successfully issued on the London Stock Exchange and the company officially became public. History was made in 2007 when Steve Jobs introduced the first iPhone to the world. That year was also the beginning of a new era in Playtech, as Mor Weiser was appointed CEO. In the following years, Playtech entered new markets in Italy and Spain, adding new licensees and products to its portfolio, including live TV shows, sports betting and the growth of bingo. By 2010, Playtech's headcount reached 1,000 employees. In 2011, First Game Studio was added and Playtech joined forces with a mobile platform developer. In Estonia, Playtech's development centre moved to its very own building on Vanamoina Street that houses Tartu office to this day. In 2012, when Queen Elizabeth II celebrated 60 years on the throne, Playtech was listed on the main market of the London Stock Exchange. Next year, Playtech diversified its profile by acquiring the world's largest independent poker school and community, PokerStrategy.com. In 2014, Playtech showcases its first ever multi-channel product and in the following year launched a complete, worldwide, omni-channel solution, Playtech One, giving players the freedom of any game across all channels, locations and devices through a single account. In 2016, when the rest of the world was mesmerised with finding new Pokemon Go characters, Playtech's Estonia site celebrated the opening of its brand new office at Ülemiste City. 2017 was the year when Batman joined forces with Wonder Woman to save the world, and Playtech made its largest ever content deal with Warner Brothers to develop iconic branded games such as Man of Steel, Dark Knight and Justice League. 2018 saw Playtech's biggest acquisition of all time, adding Snaitech to Playtech family and combining its technology and talent with the powerful local gaming brand in Italy. Today, Playtech is continuously the world's leading supplier of online gaming software, thanks to a unique combination of innovative approach and cutting-edge technology. Per day, the company serves 500 million online played games and 1 billion transactions, with 6,000 talents in 19 global locations, over 150 licensees, more than 30 regulations, and 300 gaming brands powered. Playtech continues to set the safer gaming standards for the entire gaming industry.
Hi again. Let's continue. Please take a seat. Yeah. Thank you, Playtech. It was not snack, actually. It was dinner. It quite nice things. And our next speaker would like to talk about debug autotest. It's Andrei. Welcome. Go ahead.
Yeah. Okay, does it work? Waiting for the screen. Please take your seats. Okay, now it works. So welcome to my talk about debugging automated tests. First of all, where it got inspiration, where it came from. Recently, our friend Anton Arkhipov, who is one of DEVCLUB organizers, made a speech at conferences and in DEVCLUB also about debugging Java code. He works at JetBrains, and he was talking about how to debug Java code in JetBrains environment. And he said this statement: if you write tests, basically you don't need to debug. Like, for me it was very funny. And the Oscar for the most naive statement of the year goes to Anton Arkhipov. That's why I decided to show that actually when we write tests, we still need to debug actually a lot. And I will show how and what and why. A few words about me. I'm a software developer working at Codeborne, where we had the previous DevClub, by the way, in our office. And I love writing unit tests and any kind of tests. I like test-driven development, clean code, extreme programming, pair programming, agile, and all this stuff. I am a fan of open source. I'm leading several open source projects, and I created one of them called Selenite. This is a library for writing UI tests or browser tests in Java. And because of the fact that I am maintaining open source projects, including Selenite, which is like library for tests, I often need to answer questions. Oh, why my test isn't working? Why I'm running Maven and it fails? Why? I don't understand. And trying to open a browser and browser cannot open. And I need to many times answer the same questions. That's why I'm going to show the most typical problems and the most typical techniques how to solve them. And yes, we are hiring, so we can take a look at this page also. Let's start from the most simple, most obvious, but most important things. Read the error message. When your test fails, read the error message. It seems to be obvious, but it's really important to read it, to really read and think about it. Because often I see the problem that people run tests fail, and people immediately say, I know, we need to add attributes there. I know, we need to change name, something like that. They don't even think about it. They just assume that probably he knows the solution. But if they read the real error message, they could understand that actually the problem was different. You need to take some time and read and think about it. This also includes a part that prefer tools that generate good error message, clear error message, detailed error message, but not too detailed. Let me bring some examples. Let's start from example. Here we have some test that opens a browser and checks that element is visible. And we have it in two ways. Yes, and the test fails because there is no such element. We have two ways how to write such a test. One is assert that some element is displayed, is true. Okay, is true. And the second test is written in Selenite, which says that some element should be visible. And let's compare how it looks, the error message. In the first case, the error says that expecting value to be true but was false. Like nothing that can help you. You just know that it failed and that's it. In case of better tool, you will see something like that. That element not found, and here you will see what element did you trying to find, what you expected, and what was actually, ouch, dangerous stuff. Okay. So the error message should be very, very helpful. Like pay attention to it. And it also takes screenshots, takes page source, HTML, so you can look into it and watch what was really there in this file. Okay, too big font. So you can look into this file and watch what was there. So that my point, prefer tools that generate good error message. It will help you a lot. And like compared to all the next slides, this is the most important thing, most important skill that you need to learn. And the good practice is, life hack is, when you write some tests and this test is green, it works, just try to break it. Try to break the test. Try to change something. Change locator, change expected value, and check, read the error, and check if this is really understandable, if this is really clear. Can you read this error message? Can you debug this error, or somehow understand what happened, why it failed? And can you solve this problem if it actually happens? Believe me, it happens sooner or later. Does the error message really help you to understand what happened? So yeah, look critically at your error messages. The next thing is read the logs. This is a thing that often people don't or cannot do or forget to do. Again, let's try to run another example. We have another test that opens a browser and tries to download a test. It was fast, it worked okay, but let's make a little bit bigger delay. For example, the file is downloaded during like 5 seconds, which is quite long, and test cannot do it in time, like within a default timeout. The test will fail because file is downloaded too slowly. Happens. When you try to understand why your test could not download the file, usually you see the error like failed to download the file in 4 seconds. Yeah, here is screenshot, here is page source, but it doesn't really help. You just don't know why it could not download the file. And this is probably most common complaint, that nobody knows why browser did not download the file. What happens? And if you pay attention to the logs, to what your test is writing, you will see these big error messages. Have you ever seen them before? I mean, these error messages. No? Nobody? Anybody? Have you seen them? Thank you. Yeah, I just don't believe that so many people every day see this message that says explicitly, I have trouble, I cannot log anything. And people do see it and do nothing about it for years. I really don't understand how it's possible. And actually, here is a convenient link saying what can you do with this. Actually, SLF4j is an abstract library for logging in Java, and it asks you to choose some of logging implementation. Like it should be easier, really. And usually you need to pick one of these common implementations, like either log4j or logback, basically. Like almost always you use one of them. But if you don't want to decide, if you just have tests and don't know anything about logging, you can pick this simple implementation. SLF4j is simple and it's good enough. Just write logs to console good enough. Or there is a few more implementations. If you try to improve our projects currently, like this, to pick one of these implementations, we actually do need to add dependency to our project. Where is dependencies? Here is dependencies. And we can either select log4j or logback or whatever we usually use in our projects. But in this case, it's enough to call slf4j simple. Another trick that many people forget to click this button. When you change dependencies, you need to reload the project. This button appears, and very often people add dependencies but forget to reload, and they waste half of a day to understand that I forgot. One trick is just to click this button always. Another trick is, if you don't know, there is another create button. When you go to this Gradle dialog, you have a bunch of buttons here, and you can open Gradle settings or auto reload settings, and you can click this magic checkbox, which saying that anytime build Gradle changes, please reload automatically. So we will never forget it again. Brilliant feature. Why don't everyone enable it by default always? I don't understand. Okay, now the project is reloaded. And now when we restart our test, we should see more logs. The test is trying to download the file during 4 seconds. It could not do it. And now we see the same message that failed to download file in 4 seconds. But if you look at logs, ouch, we got trouble here. Probably this auto reloading didn't work really. I don't know. Let's try again. Oh, sorry. Actually, I did add this dependency in the wrong project. I have like several testing projects here. Okay, so let's add these needed dependencies in the right project. Here I didn't have automatic reloading checkbox. If we run test again here, we should see more logs. Yeah, actually we already see logs. Just pay attention to logs that the framework is writing for you. This framework actually is writing quite a lot of logs. Currently, I have enabled debug logs, which is probably too much. But just to demonstrate, here's quite a lot of logs, and actually some logs can be very useful. Actually, it does write some useful messages that it actually did find these files. These files did not match. These files matches. Those files were too big, for example, something like that. It did write quite a lot of messages. So enable logs and take care of logs. Another great life hack is when your build is failing mystically. So you can read logs, but you don't really understand why it fails still. Another great idea is to compare, to take logs from some green build and to take logs from some red build and compare them. Just watch the diff, and then you can spot some difference. You can see the difference. I will bring another example soon. Next technique is read the stack trace. It's also unbelievable how many people cannot read stack trace or cannot scroll down the full stack trace. The very important thing that is to read the full stack trace, not only the first part. And important hack is to find the last caused by part. Usually it contains the most important message. I will bring an example. This is a simple example. Someone complained yesterday that, hey, my test don't work, and my tests do throw such an exception. Don't read it. Just session, not created, blah, blah, blah. Zillion of details, but they don't help. And we answered that, hey, please read the full stack trace. Usually people often read not the full stack trace, but until some first part. IDE often truncates some part of stack trace. But actually, if we use the hack, if we find the last caused by place, Control F or Command F, very simple. Here is this caused by part, and if we enlarge it, and large year goes by, we will see the real reason why the test fails. It could not start WebDriver because it has invalid capability, like invalid setting. So the user initialized WebDriving with unsupported setting. So it was immediately clear what to fix. He actually had to rename the settings to some newer name. Another example started very similarly, that, hey, I cannot start the test, I cannot open the browser. And when, again, we asked to scroll down to the end of the stack trace, he realized that, and yes, usually people say that I wasted a whole day on this problem. I still don't understand what happened. When he scrolled down to the end of the stack trace, he saw such caused by, the very last caused by. Who understand what it means? Yeah, great. Actually, it's very simple. It means that you are running on Java 8 tests, but actually some of libraries, in this case it was lookback library, already requires Java 11 at least, or higher. So you cannot run it on Java 8. Very simple reason, but it was hidden in the end of stack trace. And the last example of stack traces was like my real pain. I wasted some time to understand what really happened. Appium is a framework for running tests for mobile devices, for mobile applications. And after upgrading Appium from this version to this version, our tests started failing. EOS tests started failing. They started failing with a message that was not helpful at all. The message was pretty much the same as previous. Session not started, not created, and what can I do about it? I don't know. But if you scroll down, you can find at least something. We got timeout. And timeout exception is very weird because it doesn't help either. You often think that, timeout probably because Jenkins is slow, or GitHub Actions is slow, or something is slow. Let's try to restart it. Yeah, usually. But indeed, restart didn't help. We restarted many times, still didn't help. And then I started reading the logs during the green run and red run of tests, started comparing like one by one all the lines. This is like tedious action. It takes time. You need to like ignore all the timestamps, all the unimportant details. You need to read only important details. And in the end, I spotted the difference. This was the different place during OK run and knock run. Here, and I looked for a word timeout because I got timeout exception. And I found this place that when the build was green, I saw the logs that changed timeout from 10 minutes to 10 minutes. Like, looks strange, but still, it worked. And after upgrading to newer Appium, I saw logs like change timeout from 10 minutes to 20 seconds. Much shorter timeout. And yes, it explains 20 seconds probably is not enough to start Appium emulator or EOS simulator to start mobile device. It's not enough. Yes, probably it explains why we got timeout exception. Reasonable. But the question is, if you look into code, yes, in our code, in the beginning of our test, we really set 20 seconds timeout. But this code was always there. It was before upgrade also. So the question is why it started failing now, why it didn't fail before. Because this 20 seconds was always there. And after some investigation, I found the reason. It was funny, like taking account that it took like the whole day for me. The reason was that in previous versions of Appium, there was a bug. And this bug was that this timeout was just ignored. We always set 20 seconds, but it was ignored. It still was 10 minutes. And this release, they fixed the bug. Tubli, like, nice. They fixed the bug, but my test started failing because of timeout exception. Yeah, it was funny, but yeah. The next thing, read the sources. Again, I don't understand how it's possible that so many people don't really look into sources. For example, if you look in any of code, in any of tests, you can actually look into source of any of these libraries. You can look into source of JUnit, Selenium, Mockito, Selenite, whatever. You can, for example, click into this file. This is a JUnit, I guess. Yeah, JUnit. And one life hack is absolutely trivial, actually, that by default either shows you like decompiled source of this jar file, which is not really readable, but still it already provides a lot of information, but not really readable. But look at this magic button, download sources. It's so much easy. You can click this button. Ouch, what it means, I don't know. And you will see the real source of JUnit. You can debug it. You put breakpoints inside of this code. You can evaluate any expressions inside of this code. For example, if you look into Selenite code, like if you either wonder at how works method press enter in Selenite, you can click to it. Okay, the source is already downloaded, yet you can read this source code, this Java doc and so on. You can, okay, in this case, this is interface, so you don't need the body of this method, but you can see link to the source code, to the implementation. This is implementation of method press key. And in the end, we see that it just calls Selenium method send keys enter. Like sometimes it's much more complex. And you can, for example, put breakpoint here. Can you imagine? And you can run the test in debug mode, and you will stop at this breakpoint. And you can watch what Selenite is doing here. You can watch what this object is. Ouch. It contains some useful information, yeah. You can watch what this point is, this object is. So look into the code. This is my point. Yeah, click this download sources button and see what's there. Let me show a few debugging tips. Probably you know all of them, but if not, yeah, it would be visible. The first of tips is run tests. Many of us don't know it, but actually IDE suggests two options how to run tests. Look, in this case, this test was executed by Gradle. And I see it using like by seeing this icon. This is icon of Gradle, and this is default IntelliJ. It runs tests in Gradle, and but it creates some inconvenience sometimes. For example, when I currently want to run this test, it asks from me. Sorry. Yeah, it asks something from me, and this pop-up is annoying often. Often you don't understand what you want, what test, from, why. I know what it is. Actually it sees several testing like profiles in Gradle and asks you to choose one of them. Ühesõnaga, from my experience, it's often much convenient to go to settings, select this build execution, build tools, Gradle. And from this, wow, it doesn't fit to the screen. Okay, let's make smaller fonts. And from this tool, you can see these options. You can set if you want to build the project using Gradle or Maven or IntelliJ IDE itself. Or you can choose you want to run tests by Gradle or Maven or IntelliJ. And from my experience, using IntelliJ is much more convenient. It may be faster. This help text says that it might be faster. And from my experience, it generates more readable error messages often. It can better show the difference between expected and actual, and so on. So my recommendation to enable this run test using IntelliJ. The only case when it's not a good idea, if you have very, very complex Gradle or Maven scripts that generate some code on the fly, which uses some Kafka plugin, something like that, then sometimes IntelliJ cannot build your project. But in most cases, it can, and it does it better than with Gradle. So my recommendation to change to IntelliJ. Another thing that often people don't know. Let's again go to download file and run this test. The test will fail. When it fails, we see error message. Failed to download the file. And let's say we try to understand who gives this error message, where it comes from. What the exception is this? Failed to download the file. You can actually search it. You can like click the usual search, Control F, Command F, whatever, search, and here you see scopes. By default, it looks text in project, and it doesn't file because this text is not in your project, but you can click scope. And very often people don't know, but you can, for example, select here project and libraries. And then it will file this text inside of all these libraries, JUnit, Makito, TestNG, Selenite included. And in this case, we see this text in many places in Selenite. And so we can put, again, breakpoint into any of these places and like stop at this place and try to understand why it could not download the file. Another option is to create a breakpoint which will stop. If you still could not find this place, you still can create a breakpoint which will stop on any exception. Like this. Yeah, you can create Java exception breakpoint, and you can put any class name here, like file downloaded error, for example, or file not found exception. And the IntelliJ will stop at any moment when someone tries to throw such an exception. A very convenient way when you are debugging some external library, some Selenium or whatever, which you don't understand or don't even have source code, you can put exception breakpoint and stop at the moment when the exception is thrown. And at this moment, you can like evaluate all these things. You can read what was this value, what was this value. You can really debug all this stuff. Yeah, and the probably the most powerful feature of IntelliJ is evaluate expression. This is really underestimated thing. People often don't know that you can just put breakpoints at any place, for example here, start it in debug mode. And for example, you don't know which was the locator of this input. For example, you don't know, you want to check it. People often try to put different locator here and restart the test. It takes time. Actually, you can evaluate. You can put like option F8, whatever shortcut is, and evaluate the expression. You can do it as many times as you wish. You can try something different. You can check if this is visible. You can check even HTML of this element, of any element. Look, yeah, we see some HTML of this element. We can try to find article here and get the HTML of this article or whatever. So this evaluate expression is really powerful tool, which very often people don't use, but should. What's the next? One more thing that often is not obvious is what exactly breakpoint will stop. Again, if we try to debug the test that downloads a file, and for example, when you stop at the method which does the download, And now we start the downloading test. We stop it at the breakpoint. And what now happens when you go to browser and probably try to refresh the page, for example, we cannot refresh. It's hanging. It's waiting for something. If you try to click any other buttons here, it doesn't work. Nothing works. So people often complain that, hey, what happens? Selenite like breaks all my tests, breaks my browser. My browser is not working anymore. What that happens? What's going on? But what really happened that you put a breakpoint, and by default, breakpoints stop all the trades. All trades are stopped and waiting until you resume the breakpoint. But you can change it. This is really like unbelievably unknown feature. You can click like the right mouse button on this breakpoint, and this is the most important play. You can, you can check if this breakpoint will suspend all trades by default or only one trade, only current trade. And very often this option is much more better. You will stop only one trade, but all the other trades, including proxy server, will still work. And that's why all the other trades that will serve this page, look, we are stopping on this breakpoint, but the page still works. All other buttons are working because all other trades still work. Only one trade is stopped, only this trade. So this is very, very important, very convenient feature in IntelliJ. So just click this, stop only one trade. This is a very hidden feature, actually. Another debugging tip is repeat test. I very, very often use it. For example, if I have one test that sometimes fails, I should have somewhere a flaky test. No, okay. If you have some tests that sometimes fail, and it's hard to reproduce its failure, there is a very, very nice life hack to replace this test annotation with repeated tests. And you can put that, hey, please rerun this test 100 times or 10 times or something like that. And then it often helps to reproduce some random failure. The first time it works, the second time it works, third time it works, but the fourth time it fails. And then you can reproduce and can understand why it sometimes fails. Yes?
Actually, a tip of thoughts when we talk about debugging, there is an option in IntelliJ to run tests until it fails. With general annotation.
Yeah, it's also nice, yeah.
So, like 1,000 times until it fails.
Yes, it's also a way, but often I know that only one of my tests is flaky and all others are good, but I want to run all of them. Yeah, sometimes it's so that if I'm in doubt that probably they depend on each other somehow occasionally. But yeah, it's also a way, yeah. What's next? Another very, very common problem is read the dependencies. It's a very common problem with dependencies. For example, if we go to another test and run test, the test will fail with a very strange exception, probably too small font and red font. Sorry, let's run it here. I have again a very similar test that tries to download the file. Like all the stuff is pretty much the same, but the test fails. And it fails with such an exception. Class dev found error. Very, very understandable.
If you see any linkage error, guys, you have problem with the
No, actually we have problem in our code. In this case at least. The problem is with conflicting dependencies. Very often these problems, or class not found, or class def not found, or method not found, very often this problem is caused by the fact that you have different dependencies of non-compatible versions. like you have newer Selenium jar and older like Selenium Chrome jar, something like that. And very often people don't know how to resolve it. Actually, it's not always easy, but actually at least there is a way how to investigate it. If you use Maven, you just run command mvn dependency tree, or if you use Gradle, you just run command Gradle dependencies. This command will print out the dependency tree. Let's try to do it. In this project, in this sample, I used Maven, so mvn dependency tree. This is a very, very important technique. Okay, it prints out the tree into the file. Often it's convenient to put it into a file. Yeah. Now we have a file with this dependency graph, dependency tree. And we see that this is our project. It depends on this stuff. It depends on this stuff. And we recall that the method that was failing was something about Selenium. The failing method was something like Selenium has downloads, something like that. So let's look for Selenium jars. And we see that Selenium HTTP JDK client has this version, and few more jars have also this version. But, for example, Selenium Chrome driver has newer version. And they are not compatible with each other. And that's the problem. This is conflict between dependencies. This version already has method or interface has downloads, but this older jar doesn't yet have interface has downloads. That's why this class is not found. It's not always easy to resolve this issue, but at least you can find it this way. In this case, resolving of this issue was easy. We actually just need to look into all our dependencies. They are declared in POM XML, and we need to check who declares these dependencies and why. And in this case, this older version of Selenium HTTP client was really declared into the project. And I know the reason. Actually, it's not needed anymore. After some upgrade of Selenium, this dependency is not needed anymore. Like it was in older Selenium, not in newer. And if you rerun the test now, like it will work. But this was easy. Yeah, believe me, it will work. This was easy. We could spot the difference in versions between like similar charts in the tree. And if you want to find some more complex cases and more complex investigation, you are welcome to open this link. There I wrote some more harder examples. Yeah.
Enforcer.
Yes.
Special rule which checks this.
It does not always help, and often it happens that good point. We have Enforcer. I guess I have Enforcer plugin in this project. Is there? Yeah. You see, I commented out Enforcer plugin to reproduce the issue. Yes, but usually you enforces only these things that you know, that you can say. But often the problems happens with some unpredictable dependencies that you didn't think about. That's the problem. Like you know only what you know. Yes. Very good question. Yes, how it happens that minor change of minor version did the broke the tests? Yes, good question. Usually the projects that keep this semantic versioning, they should not do it. But authors of Selenium project say, fuck it, semantic versioning. We don't want to keep it. We don't believe in semantic versioning. That's it. Can you believe they even upgraded to the newer Java version in the minor version of Selenium? Yeah. Funny guys. And my favorite, like finishing the topic with dependencies, my favorite devil in the dependencies world, you probably have heard about dependencies hell. and this is a devil in dependencies hell. Usually your project using Gradle looks like this. In the beginning of project, you declare some plugins, Java plugin, some signing plugin, something else. And very often in very many projects, people, for some reason, add this line. Spring dependency management. It happens sometimes even in projects that don't use Spring, but still use Spring dependency management. And I personally cannot imagine why someone should want to add Spring into tests. Spring is not needed in tests generally until you write unit tests for Spring application. And what this beast does, it silently overrides some of your dependencies so that you don't see it in the dependency graph. It might happen that you open this file and you see that you declared version 4.13, but you see 4.11 here. And you don't see why. It's not said anywhere that why it's as another version. Yeah, and after some investigation, I realized that this beast actually overrides some of your versions without saying anything. And this is really horrible for me. I don't really understand why they do it and why people use it. But there is one cure. There is protection against Spring dependency management. The best thing is just to remove it from your project, but if you still want it for some reason, there is a cure. You can overwrite, like Spring dependency management overrides your versions, but you can override its versions by setting explicitly some properties in your project. You could ask, but how do I know the list of these properties? Look into the code. There is GitHub, there is the source code of Spring Boot, and this page lists explicitly all the versions of all dependencies it overrides for you, including Selenium. I don't understand why Spring should know Selenium version. What the fuck? Okay, if it knows like version of Hibernate, okay, good. Or version of Tomcat, good. But why Selenium? I don't understand. But yes, you can override it if you know about this problem. And now we're getting to the more harder, two harder topics, trade dumps and heap dumps, which are not often needed in tests actually, but sometimes really needed. How much time do we have? Okay, still something have. Okay, sometimes you need to look into trade dumps. Sometimes it happens that your threads are very slow or even hanging. They're just waiting for something indefinitely. And then you need to investigate it. I hope I have some working example of this problem. Let's try. Okay. This test is not hanging, it's just slow. Probably you have heard about library flying sources in Java, which can generate PDF for you. And we have few tests that check that we generate good PDF. For example, from this HTML, it generates like PDF, and we want to try to check that this PDF contains the right text. If you run this test, does it compile or what? So what happens? It's just slow. I don't know. Okay, let's close some previous browsers. I have opened too many of them. This is another tool, Visual VM, that shows all the running Java machines on your computer, and you can track them, you can stop any of them, you can take heap dump or trade dump of any of them. Yeah, this was my next tool to show, but it doesn't help to understand why we cannot run test here. What happens? Okay, let's try to just restart it there. It was some demo effect. Okay, the point is that we running the test that generates PDF, and we see that it generates it too slowly. What's now? Ah, thank you. Yeah, it was hidden here. Okay. And every time when we run it, we see that it takes 4 seconds. And only test that should be the fastest one, which generates empty PDF from empty text. So the question is why it spends 4 seconds for generating empty PDF. It's annoying when you are developing this PDF and you need to change often. The whole day you change this PDF, you're adding some styles, some text, some images, and regenerates the PDF, reruns the test, and it takes 4 seconds every time. It's annoying. Actually, yeah, this time another test was slow. Not the empty PDF, but Hello World PDF was slow. The right answer is that actually the first test is slow. When it starts in the beginning, it initializes something very slowly. So what is this? And in this case, thread dump can help. What is thread dump? This is some, let's run it in debug mode. This is like snapshot of all your working threads in your application. You can watch what they are doing right now. You can see, you can take thread dump by going to this hidden pop-up dialog and click get thread dump here, or the shortcut, Ctrl-Option-D. I will take several thread dumps now. Okay, I have rerun the test, and let's click this shortcut a few times. And during the test run, we see that this was first thread dump, the second, the third, the fourth, the fifth. And we see that almost all of them do something in the same place. We can see that all the other threads are just sleeping, just resting, do nothing. Yeah, it's actually a kind of rocket science to learn to read all the stuff. It's not so easy, but it's doable. IntelliJ helps you with some of these icons. But yeah, shortly said, all these threads do nothing, and only this thread really does something. And we see that in all these moments of time, there was at the same place. So this was a really slow place, which works 4 seconds. And when you scroll down and try to understand where it starts from our tests, starts generating PDF, and it initializes some render. Again, you can click here into SuckTrace and get into the source code of this library. You can read it. You can put breakpoints there again. But in the end, we get to the method initialize, create initial font map. It loads all the fonts. And we see that it gets to a method add CGK fonts. And this is a slow method. We can see by comparing these thread dumps that they all do something inside of this method for quite a long time. And the question is, okay, just to illustrate it once again, we do something in CGK font method. Does anyone know what means CGK font? The very slow thing that loads 4 seconds. What is CGK? This is Chinese, Japanese, Korean fonts. I also didn't know it, and now I know that this is all these Asian fonts, and there is a lot of these fonts. The really loading of all these fonts is very slow. It takes 4 seconds, and they actually occupy quite a lot of memory. And the funny fact that most users don't really need them. At least in our region, most users don't really need them. And annoying thing for us that we cannot see that this is a bug in production, because it's also slow in production, but it's really not a problem in production, because in production it takes 4 seconds for loading fonts only once, and then it works, and nobody sees any problems. But in tests, it's a problem, and this is our problem. We have to solve them. But in this case, actually, I went to Flying Source GitHub and registered the bug there, and yeah, we could fix this bug. And let's check if this is true. If we upgrade a version of this dependency to some newer version, it was something like that. This version contained my fix, actually. Okay, it automatically reloaded, nice. And if we now run the same test again, we will see that it's much faster. This is how taking tree dump can help you to improve your tests, to make them more stable or faster, and so on. Another example, if you are not too tired yet, this is already my hobby. I often debug Selenium or find some issues in Selenium. There was at some moment a deadlock in Selenium even. Selenium deadlock. And if we run this test, I managed, like after many experiments, I managed to reproduce this deadlock in Selenium. So interesting thing that the Selenium is really widely useful tool worldwide. Like in all countries, all developers do use Selenium in all companies, and it still has such bugs. It was really easy to reproduce this problem in Selenium. And very easy code. It's not complex code, it's very easy. And we have a deadlock. If you want to understand what happened, again, let's take a trade dump, this nice icon, dump trades. And here actually we have deadlock. I can detect it by watching at these icons. This red sign means that this is blocked by somebody. And we see that these two trades stay at the same place. Yeah, it's kind of rocket science. It's a little bit hard to read all the stuff, but yeah, it takes some time to navigate in it. But actually, yeah, shortly said, we see that few trades stay at the same place and waiting for the same block. They block each other and cannot move. That was a problem. And yeah, Selenium cannot even close a browser. After rerunning this test 100 times, you had 100 open browsers and out of memory in the server. So it was really painful bug. Similar bug was in Selenide. Probably not so interesting for you, but it was really interesting for me. Selenide is my library. I created it a few years ago, and at some moment I realized that, oops, I have the same problem in Selenide also. Again, the tests are hanging, waiting for something indefinitely, and trade dump helps here also. If you take trade dump, you can see that your trades are waiting for something. But this was a more interesting case, because actually none of these trades is blocked. I don't see deadlock here. They all are running, they're not blocked. But still something is blocking, and it's not absolutely clear what and why. And finally, I realized what it is. It's a known problem in Java, which is very, very hard to reproduce. Actually, this thing in Java is called static initialization deadlock. It happens when we have two classes in Java that have static initialization blocks that call each other. And when two trades at the same moment try to initialize these two classes, then they block each other. And the very bad thing from Java is that Java doesn't show these trades as blocking. Java shows these trades in the dump as running. And this is really weird. And I, again, don't understand why it's still not fixed in Java. It's really a bug in Java. And the last thing, probably the hardest one, is memory dumps. I don't know, we can skip this part if you are tired. I feel that this is probably too much already. No? Okay, the last thing, the last tool that you probably want to learn is memory dumps. Memory dump is, again, a snapshot of memory of your Java process, you can take this snapshot and investigate what takes the memory. Let's start from the issue. At some moment again, we had issue in project Selenite. After upgrading some version, blah, 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 let me show how it works. This is some specific version in the past. When I start Android tests, like my test started. Now I will open Visual VM that I already mentioned it. This is a nice tool showing all your process, and let's connect to the last process. This Gradle, worker, or whatever. This is a process that is running currently my tests. And we can, in this, like here we can see overview, we can see all the threads, we can track the state of each thread, and so on and so on. It's all very complex, but the most simplest part is monitor, and you can see the usage of CPU, the usage of classes, threads here, and the usage of memory. This is like most often the most useful part, and we see the memory consumption is growing. Like my tests eat more and more and more memory, and they don't free it up. I can click this perform garbage collector, like force running garbage collector, but we see that it doesn't help. Still, someone is consuming all the memory more and more. And the thing that helps in this case is taking a heap dump. Heap dump, we can do it with this button or from command line or from IntelliJ. There is different means, but I like to do it here. It's convenient. I can click heap dump, and it took heap dump, like saved all the memory of this Java process to a separate file. You can analyze this file, you can watch who is the biggest object in my memory, who is occupying these objects, but it takes some time. It's hard process. And my favorite tool to analyze this heap dump is Eclipse Memory Analyzer. This is a tool. This is free and it seems to me the most convenient one. And in this tool, again, this is even more rocket science. It's a little bit hard to understand what happens here. When you open this, you can open. You can file, open, and open this heap dump file. It will analyze it. It takes some time, and it will give you some overview, like what was the biggest object in memory, which objects occupy more and more memory, and it can analyze and give you leaked aspects, for example, like show which objects are more suspectful. They probably take a lot of memory, too lot of memory, or most of memory. And at some moment, I realized that, okay, now I don't remember, but I found here some object that was the biggest one. Probably, let's keep this hard part here. It's hard, it can be complex. Sometimes you need to read a lot of the stuff here. But in the end, yes, I found that our tests actually did add, with every new test, we added new listener to this test, but we didn't remove previous listeners. So we started collecting more and more and more listeners. And Selenium also had some strange behavior that it generated dynamic class for each of these listeners to wrap the WebDriver. It was some complex stuff. But in the end, we solved this problem so that we removed the previous listeners when starting a new test. So it's hard, probably in most cases you don't really need it, but if you need, you know which tools you can start with. And typically memory leaks looks like this. So the memory is growing. Sometimes it doesn't growing. It's not growing, then it's not a memory leak. And sometimes it's hard to understand, is it memory leak or not? Probably it's okay that it's growing a little bit. Sometimes it's okay. It was just a screenshot of another case when I had Spring tests and they again restarted Spring context before every test and they didn't clean up previous resources. Again, similar case. And it was actually a bug in Spring, which was fixed later in another version. Sometimes you cannot reproduce problem locally. Just in the end. All the cases I showed you could do on your machine, on your computer to run debug tests. Sometimes you cannot reproduce problem on your machine, like the test is green, but it fails on Jenkins, for example. It's complex, it's harder case, but still you can do something about it. You can add some parameters to build Gradle, to POM XML, and so on. For example, a good idea to put some memory limit when you're running tests for a test. You can decide which one is it enough, or probably you need a gigabyte for a test, I don't know. But still some limit, it's a good idea to put it. And you also, I recommend to put this option to Java machine, to the tests, heap dump on out of memory error. So it means that when your tests fail with out of memory error, it will automatically save a heap dump just to a file. Then you can later analyze it and understand what occupied all the memory. Another good idea is to add some logs for monitoring. Briefly, you can create a class like extension. You know, JUnit allows you to create extensions. TestNG allows to create listeners. You can create a rule or extension or listener which is executed before every test and after every test. And it's usually a good idea to create such an extension and log before and after every test several things. For example, how much memory is used before and after every test. And there is a million different things that you might want to log. For example, size of database connection pool, of number of used connections. Sometimes you want to log how many browsers you are running now. This helped us once to fix a bug when we had too many browsers at the same time, and they occupied again all of the memory. You might log some more things like number of opened files, and so on and so on and so on. You decide what might help you when debugging tests. So to summarize, to keep your tests in a good, read error messages, read logs, read full stack trace, find the last caused by sentence there, read sources of all your libraries you are using, know your tools, put breakpoints, create exception breakpoints, evaluate the expression. This is the most valuable technique. Investigate dependency graph, learn to find conflicts between dependencies. And probably you also want to learn how to make and read thread dumps and heap dumps. And all these techniques probably might help you to improve your tests and fix some flaky tests sometimes. Thank you for your attention.
Any questions? Yeah.
I reckon you know why selenium is called selenium. Why is yours called selenide?
Because at some moment I created a testing library on top of Selenium, based on Selenium, and I wanted to create some name that would be nice and would be something about Selenium. I just randomly started Googling some names, just like that. Yeah.
My question is comparison Selenium and Catalan Studio.
Catalan Studio.
Yeah.
I don't have experience with Catalan Studio. I heard from different people that Catalan is nice at the first glance, but later when you start using it, you can realize some problems with that. But I don't know any details, unfortunately.
Thank you. And next question: integration Selenium or Catalan Studio with GitLab. In case in GitLab you have two-phase identification, how to solve this problem?
I don't know.
Are you faced with?
No, I didn't face it. I know that in Selenium you can add, or actually in Selenite, you can add listeners to a proxy that can solve identification problem for you. You can add any listeners that can add authentication headers when sending requests to browsers. Theoretically, I guess it might help, but I don't know. Yeah.
Okay, thank you.
Anything else? No?
No. People are tired.
Yeah, I think so. I think Thank you, Andrei, for your presentation. It was really useful cases. Thanks. And present for you again.
Thank you.
And I think we are finished. See you later, maybe next month in another place. Maybe,
I guess next month will be in
December.
Yes, in December. Yeah.
Some.
It would be 7th December, I guess. Yeah.
Thank you very much, Andrei, and to thank you for this. We want to give some presents from us, so this is for you.
Ouch! Thank you.
Like this. And also, Lydia, I want you back. One small present also from us to DEVCLUB. I know Stanislav was helping me a lot with organizing, but maybe you could pass this to him. Yes, thank you. Thank you very much. And our presenter, Valdo. Valdo, are you still here? Oh! And a small bag for you as well. Thank you so much. Yes. Thank you, everyone. It was a pleasure to host you. There's still some food left, some snacks, and of course, we will not ask you to leave in 10 minutes. Let's prolong it a little bit, but maybe 10:15, we would close the event. Thank you very much, and enjoy the rest of the evening.